Alright, so we left off in the last video by finding a line of best fit and realizing it's only about a 24% good fit for that data. So we already kind of knew that anyway. Looking at the data, it doesn't look linear. And then let's go ahead and calculate for stat, right arrow for calc. And then we're going to say, oh, what about quadratic? How would that look? And if we hit enter for calculating a quadratic function of best fit, we're going to hit vars. We're going to store that one in our y2 function mode y2, enter, and have the calculator see that, oh, okay, so that r squared, that's that key number. That shows it it's a little bit better than the linear, but only barely. This is like a 27% good fit for the data. And one thing too I should say here, because it takes a while for these graphs to be drawn on the calculator, push the window button and then always change your XRes to 3 so that it'll draw the graphs faster. So you can see it goes a lot faster. So you can see neither of those functions are a good fit. So we're going to again now just follow the directions here, find the cubic function of best fit, and we hit stat, calc, and then down here number 6 is the cubic regression model, and we hit enter. We're going to store the cubic regression model by hitting the down arrow a few times. Store that in y3. We already have two functions there. I just want to show you the comparisons. You can type a 3 or you can scroll down to 3 and hit enter. And after hitting enter, then you have to hit enter a couple more times. And we can see the r squared here is now 0.74 and some change. And that's still not great, but it's much better than what we had before for the linear and the quadratic. So because it asked us to find the cubic function, we're going to find that. I'm going to show you something else here in a second. But this is what we want to write down. We want to write down y equals the a value. We're going to round these values to the nearest 3 digits after the decimal. So the a value is 0.026. Multiply that by x cubed. The b, I almost put a plus sign there, so the b value is negative, so we're going to put minus 0.3398, which means that's 4 minus 0.34, rounded to the nearest 3 digits after the decimal, x squared. And then we have I'm running out of room for my hand, so I'm going to move the calculator off, but hopefully you still have your calculator there. And then plus the c value is 1.308. 1.308. We multiply that by x, and then we have a d value, which is the constant of 0.179. 0.179. So that is our cubic function of best fit. So I want to show you, like I said, one more thing. When I look at that scatter plot, I'm seeing what looks to be, it could be quadratic, or sorry, it could be a 4th degree polynomial. So if I didn't know that I was supposed to find a cubic function of best fit, then I would also try calculating a quartic regression model. That's a 4th degree polynomial. And we hit enter, and if we store that in our y4, we're going to hit enter a couple more times, and we're going to see that the r squared is 0.908. So that's that's even a better model than the cubic. But sometimes the calculator only knows how well the model fits the data, but in real life, I guess whoever created this problem here knows that the profit's going to keep going up. So you can see the 4th degree polynomial will start coming back down. So the company is pretty sure that the profit's going to keep going up. So a cubic model would actually work better. And since we're told to find a cubic model, we're not going to be exploring all the other ones. But you need to know, you're not always going to be told which model to use, and you have to know how to analyze that. And the main thing is, if you had to explain this, that r squared for the cubic, r squared was, it was about 70% or something like that, like 0.71 or something like that. And that was greater than the ones that were down 0.26. That was the quadratic. And then we had it was also greater than the 0.24. That was the linear. So that would be your explanation if you had to explain why did you choose the cubic in this one. And if I were finding a model for this data, I would actually settle on the fourth degree polynomial, and I would say that the fourth degree polynomial had an r squared of 0.908, and that was greater than the cubic model. So hopefully that helps you, and we're going to do the same for the next problem.